So I'd like to talk about my past activity and current activity and the future research plan. So thank you for giving me this great opportunity. So I am Takuro Yonezawa from Nagoya University, Japan. So I was in several R&D projects with EUJP and also the domestic one. And I was in Keio University when we started the Cloudy project with Levent and many partners from Europe and Japan. And then we started the Big Cloudy, the following project to the Cloudy with Roger and many friends. And then I moved to the Nagoya University, and right now we are doing several research projects ongoing. And I guess most of you may not know about Nagoya, so I just showed where is Nagoya. So Nagoya City is located in the center of the Japan. It's Japan's fourth largest incorporated city and the third most populous urban area, and it is very famous for motor industry. The Toyota Motor Corporation headquarters is located in our prefecture, and I am working in Nagoya University. I guess it's one of the good university in Japan. So if you are interested more to Nagoya, please let me know. And also I'm very happy to announce that Nagoya University is ready for joining the UTA. So I'm looking forward to collaborate with you all soon. And before showing my current and future research plan, I just introduce some activities of our work in Fujisawa City. But I guess Roger talked most of the things. So I very brief show the Fujisawa City testbed. So we focus to create a sustainable ways for city sensing, analyzing, and actuating. So there are several works done in Fujisawa City, but I picked up some of the outcomes. One is as Roger said, we came up with the idea that we sensorize the garbage collection truck. So we attach the many sensors like GPS, humidity, light, UV, PM 2.5, and so we made all garbage trucks in Fujisawa City as IoT trucks, and we get many sensors every day with 100 Hz sensing. So this is PM 2.5 data visualization. So we collect the data in one day from single day. So we found that the garbage truck covers the whole load, the more than 98% of whole loads in Fujisawa City in 1 week. That should be very successful result without deploying the many sensors, just only transferring garbage trucks as IoT-ready IoT trucks. We collected many sensor data. So not only such environmental information, we also collected the number of the garbage pack from each area, and we can visualize which area should be reduce the garbage and which area should be okay for the garbage. And also we utilize the garbage truck to understand the city infrastructure. So in this case, we capture we understand how the road is damaged or not. And also we tried to open the garbage truck data by um, making the removing the privacy data from the garbage trucks camera data. And then maybe I should skip because we have no time. So this shows that with collaborating with the Steve Sass, we collected many city data, and we leverage this data for improving the city operation and everyday tasks. And also we are trying to use this data for future city planning, etc. Okay, so from now I would like to show a bit about smart city test beds in Nagoya. So right now we are collaborating with the Higashiyama Zoo. It's a Higashiyama Zoo and Botanical Garden is a very big zoo. It's a 2,500,000 500,000 visitors per year, and it has the largest area in Japan. And because this zoo is very big, large, so the management staff cannot understand how the people's visits. So actually, there are 6 gates to enter this zoo, but there is no way to understand how the people flows in the zoo. So we deploy the 40 Wi-Fi packet sensor that captures the Wi-Fi MAC address from smartphone. And Jeris, I think they are also the part of UTA. We collaborate with Jeris and correcting the people flow every day. And also we plan to deploy some smart mobilities like this kind of mobilities. And also we virtualized this zoo so we can use the virtual space for the many application. So this is a virtualized zoo. So we capture the whole zoo and make virtual worlds. So we can visualize the current status of environmental and the people status in zoo into this virtualized zoo. Okay, and also we analyze how people are flowed in zoo, which area should be popular and how the people moves from each area to the another area. And also we are creating large scale distributed simulation to understand and predict the future of urban area, especially the zoo area. And we also have another test bed. It's a Tube Central International Airport. It's a first class airport. It's the main international gateway for the Tube region of Japan. In this airport, we also deployed the people counters. So this device can count the people with preserving privacy. And our research can estimate the people from privacy protected data. So the left movie shows raw data. So there is no human flow information, but from this anonymized and privacy protected data, we generate the estimated person flow data. So this information should be very important for managing the airport. So we plan to continue collaborate with them. And last topic is the diversity. So our current research question is how urban diversity changes and what is its good effect and also bad effect. So there are some forecasts after COVID-19 pandemic. And one of the most popular working style will be the remote work. I guess many of us is now working in remotely. So this allows us to live anywhere. So we think we will have a long trend. It's a counter urbanization. So the people usually stays in metropolitan area will move to the more rural area. It's low residential cost and good food and nature. So that means that diverse people will move to the various places and area diversity will be increased more and more. And generally say high diversity has possibility to occur new innovation, but increased number of diverse people is not equal to the increased communication among diverse people. So we should provide the good communication way among diverse people. So to do that, first, we think that we have to understand how much diverse of each area and how we can communicate among them. So now we are creating the diversity method that understand the each area's diversity based on the anonymized human mobility data. And this enables us to understand diversity by classifying people's dynamic lifestyle by analyzing human mobility data. Not static information such as sex, cultural background, or income, etc. So I don't talk much there about the technical detail, but I just show our current result. So this graph means that if 1, 2, 3, 4, 5, each bar means that each classified people, for example, this is salaried people, these are housewives or old age people who are not working, or so we classify the people into the numbers of clusters, and then we check how those people equally exist in each area. In this case, this area has much diversity than this area. So we try to analyze the whole city by using our method. And last, I would like to report the interesting result. So how the diversity changed before and after COVID-19 pandemic. In the case of Nishin City. Nishin City is a better town of Nagoya business area. So we found that we expected that the urban diversity should be reduced after COVID-19 pandemic. But in this in town, interesting result we got that in total, in Nishin City, higher diversity places are increased than COVID-19 pandemic was started. We are now thinking that why this happened, because we guess that the people who usually worked to the downtown business area were stayed in the rural area, but they have to go where some places like a grocery store or drugstore, etc. So in such places, many diverse people gathers. So as a result, in this bedtown area, so we found that there are more and more high diversity area than COVID-19. So anyway, we would like to leverage this kind of diversity metric and value for creating more good cities. So we call the method as a diversity aware computing or smart cities. So if we can understand this urban dynamic diversity, we can use such information to improve the diversity, or sometimes we have to reduce the diversity. For example, in the COVID-19 pandemic, we have to keep the people's activity more low. So that means high diverse area should have a risk of infection. Or if we in the normal time, we can leverage such diversity information for providing the universal service like mobility service. For example, the public bus that has good service for older people or uh, uh, the mothers or fathers who has young children. Okay, anyway, let me conclude my talk. So I'm very looking forward to join UTA, and we are ready to start new collaboration with you all, with leveraging our experience and experimental test bed in Yonezawa and Nagoya. Thank you very much.